Today we're exploring circles, particularly measuring central angles and arcs. For this video tutorial to be effective, I will be using this format. First, I will flash each question for about 10 seconds, and you may pause the video whenever you want to give yourself time to try out each question. And finally, I will explain each question and I'll give you some tips and strategies on how to solve each question. Are you ready? Here we go. Let's begin first with the definition of central angles and arcs. In the first circle, circle B, angle ABC is called the central angle. And a central angle of a circle is an angle with a vertex in the center. So point B here is the center, so that angle is called central angle. On the other hand, an arc is a portion of a circle defined by two endpoints. For example, in circle Q, point P and point Q are the two endpoints, and the portion of the circle from point to R is what we call the arc. Use the given diagram to find the measure of each angle and arc given that segment YT is a diameter. So in this diagram, you were given that the measurement of arc WT is 50 degrees. So this means that this angle, this central angle, is also 50 degrees. Because we know that the central angle is equal to the measurement of the intercepted arc. So the measurement of angle WOT is 50 degrees, congruent to the arc WT. Now, if this angle is 50 degrees, you have here 30 degrees, then what's the measurement of this angle WOX? Since YT is a diameter, we can add 30 and 50 and then subtract it from 180 to get the measurement of angle WOX. So this is 100 minus 80, which is 100 degrees. So this is 100 degrees. And it follows that the measurement of arc WX is also 100 degrees, which is the answer for letter A. Find the measurement of arc XYZ. Arc XYZ is connecting point X, passing through Y all the way to the Z. So here, using the arc addition postulate, we need to find the measurement of arc XY and then add it to the measurement of YZ. Now, these small tick marks here means that the two arcs are congruent. So this means that 180 degrees is split up between the two arcs. So this is 90 degrees and also 90 degrees. And what's the measurement of XY? 30 degrees, right? Because that is the same thing as the measurement of the central angle. So to find the measurement of arc XY, we simply add the two arcs 30 degrees and 90 degrees. So the measurement of arc XYZ is 120 degrees. Question number 2. Use the given diagram to find the measure of each arc. Both segment DA and line RB pass through the center. Find the measurement of arc BC, measurement of arc AB, and find the measurement of arc RA. The only thing that we know here right now is that arc CD is also 30 degrees, same thing as the central angle COD. Also, we know that the measurement of DOR is also 5x. This means that arc BC is 5x and arc DR is also 5x. Since RB passes through the center, that means RB here is a semicircle. And a semicircle has 180 degree arc. So to solve for x, we need to set up the equation. 5x plus 30 plus 5x is equal to 180 degrees. So combining like terms, 5x plus 5x is 10x plus 30 is equal to 180. Now we can solve for x by itself, so we can subtract 30 to both sides. Then 30 minus 30 is 0. We have 10x is equal to 150. Now we can divide both sides by 10, so x here is 15. To solve for the measurement of arc BC, we can simply multiply 5 by the x value, which is 75 degrees now. For the measurement of arc AB, we can add 30 degrees plus 75, that's 105, and then subtract from 180. So that means this is also 75 degrees. For letter C, find the measurement of arc RA. We can also just subtract 180 minus 75 degrees. So that is 105 degrees. Question number 3 is asking for the measurement of arc URT. URT is a major arc connecting from U going clockwise, passing through R and T. So one way to do this is to find first the measurement of arc UT and then just subtract it from 360 degrees because the whole circle is 360 degrees. If arc QU is 103 degrees, what's the measurement of arc UT? We can just subtract 180 minus 103, right? Which is 77 degrees. So this is now 77 degrees. And to find the measurement of arc URT, we can subtract 360 minus that 77 degrees. So the measurement of the major arc URT is 283 degrees. Another way of solving this problem is going for a long method, which is using the arc addition postulate, which is you can get the measurement of UQ, measurement of QR, measurement of RS, and then the measurement of ST. And then adding it all up together, it should be 283 degrees as well. Question number 4 is asking to find the measurement of angle UYX. So UYX. So this is the angle that they're asking for. Using the concept of central angle again, this means that if this is 55 degrees, this also means 50 degrees. If you have 80 degrees, this is also 80 degrees. So the measurement of angle UYX is the sum of 55 degrees and 80 degrees, which is 135 degrees. Question number 5 is asking to find the measurement of the arc FGD. Starting from point F, going clockwise, passing through G, and then passing through D. So this means the measurement of arc FGD can be solved by adding 75 degrees and the semicircle 180 degrees. So the answer is 255 degrees. Question number 6 asks to solve for the value of x. For this diagram, the central angle on the left is equal to the central angle on the right. So this means that they also have the same measurement of intercepted arc. So if the central angle here is 57, this means that this arc is also 57 degrees. To solve for x, we can set up the equation. X plus 130 is equal to 57 plus 68. So this is the same thing now as x plus 130 is equal to 125. Subtracting 130 to both sides of the equation, then x is equal to negative 5. Question number 7 is asking to solve for the value of x. In this diagram, we also use the concept of vertical angles. So these vertical angles are congruent. So that means the arcs are also congruent. So setting up the equation, we have 6x minus 1 is equal to 5x plus 8. Isolating the x on the left side, I can subtract 5x to both sides. 6x minus 5x is x, minus 1 is equal to 5x minus 5x is 0, then we have 8. Adding 1 to both sides, we have now x is equal to 9. Question number 8. Solve for the x value. In this diagram, this means that this arc is 80 degrees, and 65 degrees. And we know that a circle has 360 degrees arc. So to set up the equation, we have negative 10x plus 10 plus 45 plus 80 plus 80 plus 65 should be equal to 360 degrees. To solve this equation, we can combine first like terms on the left. So 10 plus 45, 55. 55 plus 80, 135. 135 plus 65 is 200. Plus 80, we have 280. So now we have negative 10x plus 280 is equal to 360. Now we can subtract 280 to both sides. 280 minus 280 is 0. We have negative 10x is equal to 360 minus 280 is 80, and then divide by negative 10. So now the x value is negative 8. Question number 9. Solve for x in the diagram. So here, using the concept of a semicircle, then I can set up an equation. Negative 18x plus 5 plus 49 is equal to how many degrees? 180 degrees, right? Because a semicircle has 100 degree arc. Simplifying the left side, we have negative 18x. 5 plus 49 is 54, is equal to 180. Now we can subtract 54 to both sides. 54 minus 54 is 0. So now we have negative 18x is equal to 126. Now we can divide both sides by negative 18. So the x value here is negative 7. Question number 10. Find the measurement of arc HD. So here, we need to find first the value of x before we can solve for the measurement of arc HD. So also using the concept of a semicircle, then we can add 15x plus 1 and 3x plus 17. That should add up to 180 degrees. Now we can simplify the left side first by combining 15x plus 3x, which is 18x. We can combine 1 and 17, that's plus 18, is equal to 180. Solving for x, we can subtract 18 first to both sides, doing the inverse operation. And now we have 18x is equal to 162. Dividing both sides by 18, so 18 can go to 162 9 times. So the value of x is 9, and now we can substitute x is 9 to the 15x plus 1. So that is 15 times 9 plus 1, which is 135 plus 1. So the measurement of arc HD is 136 degrees. Here are the answers.